Okay, good. So we're going to go ahead and get started. I know we'll have some people who arrive a few minutes later, and that's totally fine. My name is Erik Gross, and I'm super happy to have you all here. I'm going to go ahead and get set up and then share my screen. Okay, so you are joining us for the Tech Academy's free class on hardware, software, and coding, the basics described simply. This is me, co-founder of the Tech Academy, senior level software developer, all-around nerd for many, many years. U.S. military veteran. I was in the Navy, operated nuclear reactors, and taught electronics, a bunch of other nerdy stuff. And I get great joy out of helping people understand technology and use it in their lives. All right, so let's go ahead and move on. So I have an assistant on the line here, Regina, and you can see her in the chat as co-host. And she's there to help us throughout the entire thing. All right, she will be there to monitor the chat, help me take notice of anything that I need to be aware of as I'm going through the class, and all around just help with the whole process. Quick thing, she'll be looking out for any problematic students. It's very rare that we have anybody like that. I seriously doubt we will tonight. And if you're not a nice person, she'll probably give you the boot, but you're all nice people, so you don't have to worry about it. I've already asked you to start doing this, is to use the chat and just introduce yourselves. Chat is pretty straightforward. If you haven't used Zoom, you should find the chat icon in your control bar, and you'll be able to send something to me or to the co-host. For most things, please just send it to the co-host if you have questions, because as I'm teaching, it's harder for me to monitor the chat, but that's why Regina is here. So if you have something you want to ask as a question, we are going to have a Q&A at the end, but Regina will be monitoring messages that go to her. So please send chat questions to her. So who are we? What is this organization that's giving this free coding class? Well, we're the Tech Academy. We are a software developer bootcamp company. We help people break into technology, become well-rounded entry-level developers. So there'll be a brief explanation of that, right? Well, then we're going to have a workshop, and the workshop is all about hardware basics. And the fact is, to be a software developer, you do need to understand certain things about how the hardware of the machine works. It can actually help tremendously. And we find that it's not something that's covered very well in existing boot camps, or honestly, in many places at all. And so we want this free training out here to help remove any mystery about the hardware inside the computer, and to have you start to relate that to software and software creation. After we've done the workshop, which will be about 25, 30 minutes, we'll have a Q&A. You have an opportunity to get any questions, a few questions answered. We'll tell you a bit about who we are and our boot camps in case you're interested. And please do stick around to the end, because we have a free gift for you. I think it's something you'll really enjoy. So the whole thing should take about an hour to an hour and a half tops. We're going to try to keep it pretty tight and respect your time, while also delivering a lot of value and really, really helping you. Now, let me tell you a little bit about our school, very, very briefly. So the Tech Academy is a coding boot camp founded, oh, wow, today's the 3rd. So we were founded 10 years and 2 days ago, right at the very beginning of 2014. So it's our 10-year anniversary, which is fantastic. We provide cost-effective, self-paced online certification programs. Our programs are self-paced. You can start anytime, which means if you know something well, you can just screen through it. And if you need a little more work on something, you are afforded the time to work on that, which means you're never going to be left behind, which is really cool. We have a lot of attention on making sure you learn what's actually being asked for out in the marketplace. You learn in-demand skills rather than something that is a flash in the pan or was popular 5 years ago. We want you to have really good skills. But we also want you to have a good long-term career, and that's reflected in the mission statement of our school. And our mission statement is to graduate entry-level technology professionals that excel in the basics of their field, and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's what we're all about. All right, If you're at all interested in that, you can fill out a contact form. My assistant's going to put something in chat for you. You can go to learncodinganywhere.com/Erik. That's Erik with a K, which is the correct spelling of the name Erik. My apologies to anybody whose parents spelled it wrong, but it's meant to be spelled with a K. Thank you very much. So you can go to that link and find out more. I'll give anybody who's interested in that 1 minute to hop on and fill out that form. And then we're going to jump into some awesome content. All right. That's fantastic. Again, learncodinganywhere.com/Erik. You can go there anytime. Okay. So I want to cover what this class is and isn't. We're going to cover a lot of common coding terms and technology concepts, right? Some fundamental programming concepts, all related to what's under the hood, the hardware of the actual machine that computer programmers, work with. We aren't going to write code, right? I'm going to be holding an intro to coding class in a few days, by the way. And if you go to, let me pull this back up. I apologize. If you go to our link that we're going to put in our events link, there it is in chat right now. My assistant Regina just put this in. If you're interested in learning how to code, and especially in learning how we teach people to code, because we're really good at it, then go to that events link that we just dropped in chat, and you can sign up for my future coding classes. They're a lot of fun. You get your hands dirty. You actually do write code, and we explain every single line of code that you're going to write so you can actually walk away with greater understanding and discover how much you like coding, whether it's for you. So we're about to talk about what's inside a computer and hopefully try to remove some mystery there. But before we even cover that, I want to explain what the purpose of a computer is. And perhaps you've learned this in the past. Maybe no one's ever told you. But at a very high level, the purpose of a computer is to take in some data, to process that data. That means to work with it in some way, and then to send that data out. Now, I know that seems very, very simple, and it is simple, but most fundamental truths about any area of study are actually very simple. And the better understanding you have of the fundamentals of an area, the better job you're going to have, the easier job you're going to have laying on complexity above those fundamentals. And this is factually what the purpose of a computer is. This is why we created them in the first place 70 years ago, is because we wanted machines that could take in data at a very, very rapid pace, could process that data, do work with it at a very rapid pace and without making mistakes, ideally, and then send that data out. That's why we made the machines. And what we're going to learn about today is, what does the physical machine look like that can actually do this, that can take in data, process it, and send the data out. That's what tonight's class is all about. So we do want to differentiate right at the beginning the difference between hardware and software. Hardware is the physical components of the machine, these computers. And there's a lot of different components. You can see a lot of them illustrated on the screen. Software is the instructions to make those machines operate the way we want to. Hardware versus software. And again, this is a term that many of you have already encountered, but I just want to set the stage here. And by the way, cool little, not that commonly known fact, there is a slang term in the industry called wetware. Hardware is the machine. Software is the computer programs on the machines. And wetware is us, human beings, people. That's not an official term, but it's very common in the computer industry. We are the wetware. All right, so you've got hardware above, and you can see lots of things there like printers and keyboards and joysticks. And then down below, lots of symbols for software. I just want you to I want to make sure we're setting the stage correctly. So let's look at a common desktop computer system. We're going to dive deep inside it, but I want to be able to differentiate between the different parts of it. So what we're looking at right here is called a monitor, also called a display, also called a screen, right? We use this term universally, interchangeably. These terms are used. I want you to keep in mind, for everything we're going to show you on this slide, and frankly, all of the rest of the slides here, the actual purpose of a computer: to take in data, process that data in some way, and send that data out. This device you see on the screen is part of the final stage of sending data out. The computer will send data to this really cool device called a monitor and create some sort of an image on the screen. So it's part of the third element of the purpose of a computer. And it's called a monitor, so you can actually monitor the output of a computer. This is a tower. Now, they don't all look like this. Some of them are short and squat. Some of them are much bigger. But the tower is what we're going to dive into today. This is where all the actual physical components that accomplish the purpose of a computer are positioned. They're all inside this box. We're going to unpack that and see exactly what's inside, which is really cool. Okay. This is a keyboard. Again, we all know this. But again, look at this in light of that simple explanation of the purpose of a computer: to take data in, process it, and send data out. This is one of the ways to get data into a computer, is a keyboard. Here's a mouse. A mouse is also used to get data into a keyboard. Now, those of you who are gamers know that you can also get information from the computer to the mouse sometimes. They have these cool little, they call them haptic, devices inside. That just means a physical sensation. In other words, that mouse can vibrate. So it's also important to know that some devices can do both, getting data into the computer and receiving data from the computer. In fact, many of you have touchscreen monitors, and they can get data from the computer. And when you touch them, you're getting data into the computer. This whole thing is a desktop computer system. Again, many of you have one. Why is it called a desktop? Well, let's go back about 50 years to the early 70s, when computers up to that point were massive, gigantic things. They were called mainframes, and they, at the beginning, literally occupied an entire building. Then they got them down to the point where they occupied a room. Then they got them down to the point where you could occupy, 6 or 7 of them in a room. And the computer professionals of that day and age dreamed about the day they could have a computer so small that an office worker could put one on their desk. So whether they're on your desk like mine, or under your desk, or over in the corner connected by a bunch of wires, this is why they're called a desktop. Because there are other forms of computer, but what we're talking about right now is the computer that most of us use all the time. This is a desktop. Now, we also call this a PC, or a personal computer. And again, it goes right back to that time 50 years ago, when the idea of a computer that someone could have at their own individual desk in the workplace or in their home was a dream back then. And very few people could actually afford computers. As we moved into the 70s, and especially the early 80s, the cost of components and the size of the machine got to the point where people could have their own personal computer. It's important to understand that there are other types of computers. Mainframes, for example, are still being used today in lots of companies. Many people have never seen one. I've never actually seen one. It'd be kind of cool. All right, so that's a desktop computer system, also called a PC. Now, here's where we get to have a lot of fun. The computer is a machine, and machines are simply tools that human beings devised to do work for them. A horse and buggy is a machine. A car is a machine. A rake, a shovel. These are all machines in some way, shape, or form. But the most common understanding of a machine means that it's a tool made out of various manufacturing materials like glass and plastic and metal, some moving parts, some non-moving parts, that accomplishes work for human beings. Most machines on the planet use energy in the form of electricity to do the work. Now, why do we care about this? It goes back to the purpose of a computer: to take data in, process that data, and send the data on. That is actual work that's being done. Even though it's inside this magic box that sits on or under your desk, work is being done inside that machine. And we're going to break down the pieces inside the machine that are doing the work. We start right here on the power supply because any machine needs some source of energy to do its work. So we take electricity from the outside wall using this cord or cable, and we get electricity from the outside wall there inside the machine. Now, this next part is really cool. Without being all nerdy about electronics and electricity, which you don't really need to do right now in the confines of this, brief class, it's enough to understand, to help you understand that when we take the electricity from the wall, that electricity coming out of the wall is way too powerful for the tiny components that are present inside a modern computer. And so we need to do something really important. We have to reduce the energy level of that electricity. We call that voltage. Those of you who know a little bit about electricity probably already knew that. So one of the things this power supply does is take the voltage, the electricity coming from the wall, and drop it down to a very low level, so that when we then use that electricity inside the computer, it doesn't blow everything up and burn things. That's one of the purposes of the power supply. The other purpose of the power supply is to make sure that when the voltage coming out of your wall fluctuates slightly up or down, which does happen, by the way. Have you ever noticed like your lights flicker, or they get dim sometimes, or they get bright? That's the voltage level coming out of your wall changing. Well, modern computers are very delicate machines, and they need a precise, exact level of electricity in them. If they don't have that, they can't operate well. So the power supply also regulates or smooths out the electricity inside the machine, inside the computer, so that it has a stable source of energy. This is the back of the tower, showing you where the power supply is. Now, many of you have never seen one of these power supplies. That's because they're literally inside the box. If you were to go down under your desk or turn your tower around if it's on your desk and look at the back, you'd see where the cable goes in. And the thing that it's plugging into is your power supply. Notice also the grate there with the little holes. These power supplies, when they do their job, give off a lot of heat as they drop down the electricity level, the energy level. And so that's why you have a fan in there, and that's why you have the holes, and so the heat can get out of this machine and doesn't stay inside the tower, doesn't stay inside the box. All right. Now, we've got electricity into the machine. Let's talk about the most important place that we send the electricity. We need to get electricity to what's called the central processing unit, or the CPU. This is the brains of the whole computer. These are highly complex electronic systems with billions, literally billions of individual devices on them. But the purpose of it is, you'll never guess, to take in data, to process that data in some way, and to send the data on. This is the part of the computer that does the entire purpose of the computer. This is the part that controls taking in data, working with it, and sending it on. That's the central processing unit. Again, think of it as the brains of the outfit. Now, we could have a 2-hour-long session or class about the CPU. And when you go through our boot camps, you learn exactly how this thing works. And it greatly increases your knowledge and stability as a software developer to know how this thing works. But it's enough for right now just to know that it's the brains of the outfit. It controls taking in data, processing the data, and sending the data on. Now, sometimes your computer needs specialized functions. For example, computers need to connect to the internet. Computers need to do special things related to playing games, because when you use a computer to play video games, many of you play video games know this, there's a lot of work being done that's very specialized in terms of rendering those pictures on the screen. And there are several other things that computers standardly don't come with, but you want to add on additional features. To do that, we have these electronic devices called cards that you can add into your computer. Think of them as like special features that you can add in. They're bonus packs is another way to kind of think of them, right? But they're just electronic devices. They're called cards. Again, every single one of them assists in taking in data, processing the data, and sending the data on. It all comes down to that. Here's an example of a card that many of you have probably seen or know about. This is called a graphics card or a graphics processing unit. Now, this is a lot of fun. This is actually a mini CPU. It's a mini processing unit. Those of you who play video games know that these are super important. And the reason for it is you've taken a computer that comes from the manufacturer and you want to do something specialized with it. You want to be able to play games, and games require processing a tremendous amount of data and sending it to the screen very quickly and receiving input from your joystick or from you touching the screen very quickly. Your regular CPU is busy doing lots of other things, and the CPU can turn to this graphics card and say, hey, listen, your job is solely to handle processing data related to the images on the screen. That's your job. And so now you have this mini computer, if you will, this graphics processing unit that handles everything related to the images on the screen. It's kind of cool. By the way, all of this, all these concepts of cards and the GPU and these specialized functions, these things are all covered very thoroughly and detailed on our boot camps. Here's another example of, this is an example of what's underneath those fans. I said that this GPU is a mini CPU. Well, what you're looking at in that bottom image is one of the CPUs that's inside a graphics processing unit. It's very similar to the first one I showed you. That's the main CPU for the entire machine, because this GPU needs to take in a lot of data related to images on the screen, and it needs to process that data, and it needs to send it back so it can get to your monitor and do all that super, super quickly. All right, now let's talk about ports. Ports are places where the input and the output happens. Remember, the purpose of a computer is to take data in and send data out. Ports are physical places on the computer where that data in and out can occur. And there are, if you've ever looked at the back of a computer, tons of different ports. Each one of these is there to allow electronic data, i.e. little electrical signals, to come in or come out. That's what these ports are for. There's lots of different devices they connect to. You're probably familiar with some of them, like printers and displays and joysticks and modems and all this kind of stuff. The most important thing to remember is that these are ways that the input and the output happens. Now, I want to start to tie some of this together. This part's kind of cool. This is what's called the board or the motherboard. It's probably not a surprise to you that modern computers have a tremendous number of tiny electronic components inside them. Now, again, we're not going to get super nerdy about what those components are like and how they work. You do learn a lot about that on the boot camp. For now, just know that this physical piece of material you're seeing in front of you has billions of tiny electronic components on it that are all dedicated to accomplishing the purpose of taking in some data, processing it, and sending it on. This board is directly related to ports, and I'll show you how. So here's this motherboard, okay? This is a much more complex board than the one I showed you. This is an example of a very realistic board inside a modern computer, and you can see there's a ton of things going on here. Before you get overwhelmed with the complexity, just fall back on the stable fundamentals of take in data, process it, and send it out. Right smack dab at the bottom, like lower third of it, you'll see that silver piece. That is the CPU. In fact, I'll move my cursor there. That's the central processing unit, okay? Lots of these other devices you see on here are where you would put in the cards that we talked about. It's where you would get input and output from keyboards and monitors and mice and all this kind of stuff. But again, this whole board is only there so the CPU can have a place to live, and the CPU can be connected to places to take in data and send data out. So here we see ports combined with a motherboard. They are physically installed on the board. They're at the bottom there. They're circled in red. Those are places that data can come in and out. Now, Why are they physically attached to the motherboard? Because the motherboard is where the CPU lives. And if we're going to get data to the CPU and extract and have the CPU send data out, we want to have the actual devices where the data comes in and out in close proximity to the CPU. In fact, directly on the physical board. This makes it so there's a very tiny distance between them. And believe it or not, electronic signals actually take time to travel from one end of a wire to another end of a wire. The closer, the shorter the distance, the faster communication can occur. The faster the data can get into the CPU and out of the CPU. So those are ports. Here you see what that looks like from the outside of the machine. You can't see the motherboard, but it's right on the other side of that silver plate. It's right on the other side of this little area right here. And in fact, all those ports are connected, just like we see down here, to the motherboard inside the machine. This little electronic device you see here is called random access memory. Now, if we're going to go off of this fundamental that the purpose of a computer is to take in data, process it, and send it on somewhere, the next layer of complexity to add on is that sometimes when the CPU is doing its job of processing data, it needs to store the data somewhere while it's busy working on something else and then get back to it. And that's what random access memory is for. Here's an example. Let's say you have your browser open and you've got 50 tabs open like we all do. And there's 30 or 40 of them that you haven't even looked at in like a week. When you click on those, remember that it takes a little while for them to appear. But if you revisit a tab that you just were at 30 seconds ago, it doesn't take very long for that stuff to appear. Why is that? It's because your computer will take the tabs that you have that you are visiting regularly, like every few minutes or so, and keep all the data from that browser tab in RAM, in this memory. But if you go a few hours or so, or a day without looking at a tab, your browser, in an effort to help your computer work more efficiently, will give a special instruction and say, hey, take this out of random access memory and store it somewhere else. We're going to get to where in a moment. But just to illustrate what this random access memory is for, it's for temporary storage for data that is being used in the moment, if you will. This random access memory device you're looking at on the screen gets installed into the motherboard. And we're going to see that in a moment. Remember those blue tabs that we saw on the motherboard earlier? In fact, I'll go back up and show you a motherboard. There's a nice one. Look at the blue tabs on the bottom right down in here. That's where you put the RAM. Let's go back down to that image of someone putting RAM in. This is someone actually installing RAM in. Now, one of the reasons I also, when we chose this picture, is that it shows you that you can actually switch this out. One of the biggest improvements you can make to a computer's performance is to give it more memory to work with when it's doing its job of taking in data, processing the data, and then sending the data on. If you get RAM memory, right, which can store electronic data, if you get a new piece of RAM that can operate faster and or can hold more data, your computer can do its job better. And so you can switch these things out. It's a lot of fun. Always unplug your computer before you do anything like this. Thank you. Oh, by the way, one of the cool things about this, you may wonder why it's called random access memory. Why random? You learn all the details of why it's called random access memory on our boot camps and why that's important. So we just discussed a type of data storage called random access memory that's there. It's meant to be used while the computer is doing its job. But what about when you turn the computer off and you still want to store some data? That's what drives are for. They are for permanent storage of data. One thing to know about RAM is that when you turn the computer off, all of the data in there goes away. Bye-bye. It's wiped out. It's only there for when the computer's running and the CPU needs a place to store some data. Once the computer's not running, it's gone. Drives are where you store data that doesn't go away when you take away electricity from them, when you turn the computer off, which is pretty cool. Oh, by the way, I just realized that there's a really cool thing I didn't clear up. We're going to go back up a little bit because it's really nifty. It'll take about 20 seconds. Let's go back to the power supply here. Look at that button right next to the place where you put the cable. I'll pull the cable up. Everybody notice how that button has these two symbols on it. There's a round circle and a vertical, looks like the letter I. And you'll see those two symbols being used on hundreds of thousands of different devices around the world. Millions, billions, actually. You've seen this on everything. What is that? Why does it say on and off? We've all intuited that when you click the 0 part, it turns off. When you click the 1 part, it turns on. But why? That has to do with the fact that the electronic data that we work with inside of a computer is represented as zeros and ones. Now, why? That's a subject for a whole nother class. When you represent quantities with the numbers 0 and 1, you're using what's called a number system called binary. It's a lot of fun to learn. It's vital to understanding how to program computers. But the symbols of 0 and 1 leaked out into society and now are almost universally known as off and on. 0 is off, 1 is on. So just want to share what that is. All right, so let's get back down to where we were. So we're pulling all this stuff together. Or maybe I should learn how to operate a slide deck. Give me just a moment. That was way too fast. All right, so we're looking at drives, right? This is where you store data. And what made me think of that 0-1 thing is, again, you'll learn a lot more when you do a full-blown class on this, but the data that's stored in here is actually data represented as zeros and ones, or off and on, or true and false. And RAM, that we looked at a few minutes ago, it does the same thing. It stores data as zeros and ones, but when you turn the computer off, like I said, all those zeros and ones get wiped away. They disappear. These devices are different. When you turn the computer off, the zeros and ones stay on the device. They stay the way they were set before the computer got turned off. It's called persistent storage of data, and it's really valuable. This is where all of your documents and your files and your programs are stored so you can use them when you turn the computer on. There's lots of different types of drives because there's lots of different ways to store this electronic data. One of the ways to store electronic data is through what's called an optical disk. Optical just means relating to light, and it has to do with the fact that the way we store data on those disks and the way we read data from the disk, we use light to do it. We use a laser. That's why they call them optical disks. You may know them as CDs or compact disc, DVDs, which is digital video disc, and Blu-ray discs, or Blu-rays, which is a Blu-ray disc. But they're all optical. They all store data using light, using a laser. All of it is persistent storage of data. Here's an example of the actual physical device called a drive, where you put the actual disk in. Again, we've probably all used these things. Just want to clear up some of the terms. So another way we permanently store data is on what's called a hard drive. You notice that there are, in fact, 3 different disks here, one down below, one in the middle, one on the top. These disks are metal, and they're coated with magnetic material. The little arm right here can move around on the disk while the disk is spinning, and it can either change the data on the disk or read the data that is on the disk. This is how data gets stored and read from storage. This is what hard drives are all about. And again, this is persistent. when the computer gets turned off, whatever data happens to be on this surface, on this disk, stays that way, even though there's not electricity inside the computer, which is pretty amazing, honestly. All right, so let's lift up the hood and we'll see where all these devices are. Where are they? Well, here's the power supply. Notice that even though it's not shown, the cable would come in from the left here and it would plug into the power supply. That's where your voltage from your wall socket comes in. And the power supply drops that voltage down to be very tiny, very small. But notice all these cables come from out of the power supply and they go to everything inside the computer that needs electricity to do its job. Things like the drives over here. These drive, well, we'll get to those in a moment. All right, so here's a graphics processing unit inside the graphics card. Notice this graphics card is installed on, and you can all predict this hopefully, the motherboard. There, in fact, is the motherboard, which is where all of the work gets done because that's where the CPU is, underneath this little device to keep the CPU cool. Another thing to know is, look, if we said the CPU is the brains of the outfit, it's where all the work is done of taking in data, processing it, and sending it on. That's a lot of electronic signals moving through a very, very tiny device. And when electricity moves through things, it generates heat. And so you got to find a way to keep that CPU cool. This here is an example of the RAM that we talked about. Again, notice that it is in close proximity to the CPU because that's what the CPU is going to store data it needs to work on right here in the RAM. Here's an optical drive, a way to store permanent data. And here's a hard drive, another way to store permanent data. So if you've never taken the cover off of a computer, now you know what's inside. If you have, you've probably seen some of these things, and some of them maybe you knew what they were, some of them maybe you don't. I again want to caution you, if you are going to open up a computer, always unplug it from the wall. Because even though this power supply here drops the voltage down, you do not ever want to stick your hands inside a piece of equipment that has a live electricity in it. One, you can damage yourself. Two, you can damage the machine. And as we all know, computers can be kind of expensive. All right, so that's what we've covered. I know it was a rather whirlwind tour through a computer. I want to give a couple minutes here for Q&A. So if you've got any specific questions, put them in the chat. Send them to Regina, and she'll forward them on to me. And I'll answer any questions we can. We've got time for a couple of them before we end off.
I got a couple questions.
Oh, good. Excellent. What do you got?
Time for them.
Yeah.
All right. So first question, why would we need an external server if a single computer can do the heavy lifting?
Oh, I love that. Okay. So that's a great question. I was being quite simplistic when I said the purpose of a computer is to take in data, process it in some manner, and send it on. But again, it's very true. You do need to consider what kind of processing is needed. So while we don't have time to get into a full breakdown of how a client computer and a server computer will work together, it's enough to know this. If you will take a super powerful computer and call it a server, and when I say super powerful, I mean a very fast central processing unit and lots of memory. If you'll take a computer that is capable of that and call it your server, and then have other less powerful computers that can connect into it and call them clients, now you can get the computing work done in a different manner, and in most cases, a lot better than if you just have one computer. For example, in an office, you might have a bunch of administrative workers in an office, and you can buy them really inexpensive computers to go on their desktop. Super cheap, which economy matters for a company. But you can have the computer programs they use that need to process a ton of data really fast, all be installed on that one server computer, like in the basement or whatever, in a nice, cool room, because a computer that big will put off a lot of heat. And now you can have the client computers, which again can be very underpowered. They don't have to have very fast CPUs. They don't have to have a big amount of memory. When they need work done, server, and let it do the heavy lifting and send its completed work back to the client computer. That's one example of why you might do that. And I hope that helps. Hope that explains that. Again, you get a full breakdown of how you would divvy up the computing workload, how to connect computers to be able to work together efficiently. All this stuff you learn on our boot camps. But that was a great question. Any other questions, Regina?
Believe we have time for one more, and then as Erik said, please feel free to contact us for further questions. But someone wants to know, just to confirm, RAM continues to store data when a computer sleeps, but it is not turned off.
Yeah, that's a great question. Although that's a brilliant question. Again, there's a lot of nuance there. To simplify it, yes, when a computer goes to sleep, quote unquote, what it's trying to do is reduce its power consumption. Okay. And all that data that the CPU needs to remain in RAM will stay in RAM. You're not going to lose it. It's only when you actually turn the computer off, either by going to the back and flipping the switch, or by using the operating system's controls and going to shutdown, right? So yeah, great question. It does, in fact, stay even when the computer's asleep. Good. Excellent. All right. So a brief word again about who we are, a little more data. So we're a bootcamp provider, but we don't just have one bootcamp. We actually have 12, which is pretty phenomenal. We cover all kinds of subjects, from computer programming to user interface and user experience to design, artificial intelligence. This is a phenomenal bootcamp, by the way. I think we've all kind of heard about AI a little bit in the last year. We have boot camps on game development, like you name it. If you want to specialize in tech, we have it. A real important thing to remember here. Oh, by the way, please do stick around through this because I have a free gift for you at the end. I think an important thing to know here is that we are certified through the Higher Education Coordinating Commission, which is a very challenging cert to get. In fact, lots of boot camps don't have this. That means that we get thoroughly reviewed on an annual basis for our curriculum to make sure it's really, really good. And it is. Here's some of the awards we received. We've received these year after year after year. As I said earlier, we've been around for 10 years as of 2 days ago, which is fantastic. And each year we get acknowledged by our peers. Give me just a moment. Back to the end here. Oh yeah, we get lots of really good reviews because we do a really good job and we work really hard for our clients, and they're very happy with us. We have an average 4.8 star review rating across all of the major platforms, and we're proud of that. We work really hard for that. So if you'd like information and a free coding bootcamp guide to help you sort out what kind of route you might want to take, how to break into technology, you can go to learncodinganywhere.com/Erik, and we will send you a free coding bootcamp guide. Now, that's not the free gift. I have that coming up in just a moment. But I'm going to leave this link up here for a moment, and Regina just put it into chat as well. And I'm going to allow just a minute here for anybody who wants to log into that and ask for more information to do so. And they're going to show you how to get your free gift, which is genuinely cool. By the way, if you happen to be an existing user of the Tech Academy and you don't quite know your login credentials, we provided what they are down there below. That's for a small subset of the audience. Okay, good. All right, so this book is awesome. Jack and I wrote this a while back because we found that when it comes to understanding the business of actually making software, how do you manage software projects? It was incredibly complex and hard to understand. I don't know why it was made that way, but it was. And so one of our fundamental approaches in all of the training we do is how do we simplify material so that you actually understand the fundamentals really well and then can add on gradual layers of complexity. And that's what we've done with the project management handbook, right? for anybody who is in America, we can't ship this overseas. I apologize. But if you're in America and you want a physical copy of this book, we will send one to you free of charge. All you have to do is send an email to books@learncodinganywhere.com, include your mailing address, and we'll fire one off to you really, really quickly. That email address is also in chat because Regina put it there. And I give anybody who wants to send off an email like that a moment. Again, just your name, your physical address, and we will send off that project management handbook. That's for you. All right. So we've reached the end of the class. I super appreciate you all for joining us. Please join us for future free coding classes, free computer training classes. You'll find all of them at the meeting link that we put earlier. But again, there's the link if you want to request any information about our boot camps, who we are and what we do. You're welcome, Danielle. I appreciate your thanks. I love doing this. Join us for more of these. We do them twice a week right now. And if you go to the events, Regina, can you go ahead and throw that link in there again? You're welcome, Mike. Can you throw that link in again for future classes into chat? Okay, good. So if you want to do more, if you want to join us for more of these, the link for our meetings is right there in chat. You can log in right now and join us for our next one, which is a free coding class in JavaScript. You're welcome, Auntie. Yeah. Oh, yeah. Happy New Year to y'all as well. Oh, Mike asked if there's going to be recording this meeting. We are putting this meeting up on YouTube. It usually takes 2 or 3 days to get it all edited and put up on YouTube. But if you go to the just search the Tech Academy on YouTube, you will find our channel, and in there are free coding resources, or free learning resources, and you will find this on there in about 2 or 3 days. You're welcome, Jocelyn. All right, good. Thank you all so much. Appreciate it. And I'll stick around if anybody has any more questions they want to throw into the chat. Otherwise, y'all are free to go. And I really appreciate you being here.